Bismillahirrahmanirrahim. For today, we are going to speak about the derivatives of exponential functions. You know that the exponential function is defined by b to the power x, something that b to the power x, where b is positive number not equal to 1, is an exponential function. We say this is exponential function. And we know that the exponential function is the inverse of the of the logarithmic function. The exponential function is the inverse of the logarithmic function. And for the logarithmic function, we said that the derivative of log is equal to f of prime divided by f of x multiplied by ln of the base. For the logarithmic function, we divide by ln of the base. For the exponential function, the derivative with respect to x is equal to b to the power x multiplied by ln of b. So the derivative of exponential function is b to the power x equal to b to the power x multiplied by ln of b. And for the natural one, d by dx of, if the base is e, then I will have e to the power x, where, as we said before, e is just approximate number equal to 2.71. This constant. In general, the derivative of the exponential function b to the power f of x is the general form when the power is not equal to x. This is equal to b to the power f of x multiplied by the derivative of the power multiplied by ln of the base. This is the general form of the derivative of exponential function. d by dx, or the derivative with respect to x of b to the power f of x, where f of x is differentiable function. The power must be a differentiable function, is equal to b to the power f of x multiplied by derivative of the power multiplied by ln of the base. Let's explain this with some examples. Find the derivative. Number one, that y equal to 2 to the power 3x. This is exponential function. Y equal to 2 to the power 3x, the derivative y prime is equal to the function itself, 2 to the power 3x multiplied by the derivative of the power. Derivative of the power is equal to 3 multiplied by ln of the base, which is 2. So it is 2 to the power 3x multiplied by 3 multiplied by ln of 2, or just we can write it as 3 ln of 2 multiplied by 2 to the power 3x. Just rearrange it, putting the constant in front of the function. Another one, number 2, y equal to e to the power sine x. So the derivative, it is y prime equal to the function as it is e to the power cosine x multiplied by the derivative of the power. Derivative of cosine is minus sine x multiplied by ln of e. Ln of e is equal to 1. So that's when we have base e, no need to write ln of e, because ln of e is equal to 1. So this is equal to minus sine multiplied by e to power. So this is the derivative. Number 3. Y equal to, take e to power square root of x. And we need to find the derivative. So the derivative of y prime is equal to the function as it is, e to power square root of x multiplied by the derivative of the power, derivative of square root of x. That will be 1 over 2 square root of x. So that's it. This is the derivative of the function y equal to e to power square root of x. Number 4, that y equal to sine of e to power x. The derivative of y equal to sine e to power x. We need to apply the chain rules. This is chain rule. The derivative y prime is equal to, even in the example number 3 and the other one, also we apply the chain rule. But this one will be clear here. Because I have a function inside another function, this is a composition of two functions. So I need to find the derivative of sine, which is cosine of the angle as it is, now change in the angle in the first step. Then we differentiate the exponential function, which is e to power x. This is by the chain rule. I have two functions, so I must have two derivatives. So it is cosine of e to power x multiplied by e to power x. Number 5, y equal to x squared multiplied by e to power x minus 1. X squared multiplied by e to power 2x minus 1. Since we have multiplication of two functions, we must apply the product rule. That is f prime g plus g prime f. So the derivative in this case by the product rule, y prime is equal to, derivative of the first one is 2x multiplied by e to power x minus 1 plus. Now the derivative of the second function, which is e to power 2x minus 1 multiplied by the derivative of the power. Don't forget that we have to take the derivative of the power, which is 2. Multiplied by ln of e, no need to write it, multiplied by the first function, which is x squared. So this is the derivative. Y prime equal to x multiplied by e to power 2x minus 1 plus e to power 2x minus 1 multiplied by 2 multiplied by x squared. Number 6, y equal to e to power x minus e to power minus x divided by sine x. Since we have fractional function or rational function, I need to apply the quotient rule. For this, we need to apply the quotient rule. That is f prime g minus g prime f divided by g squared. So the derivative in this case, y prime is equal to, for the denominator it is sine squared, and the derivative of the numerator, that will be e to power x plus e to power minus x multiplied by the denominator, which is sine x minus. Now derivative of the denominator, that will be derivative of sine is cosine. x multiplied by the numerator, which is e to power x minus e to power minus x. So this is the derivative using the quotient rule. Take one more. Number 7, have y equal to ln of 2 to power x minus 1. And we need to find the derivative for this one. Y equal to ln 2 to power x minus 1. From the derivative of the logarithmic function, we know that the derivative for ln is f prime divided by f. So y prime will be, the function is 2 to power x minus 1 to this part. This should be in the denominator because I have ln. Now the derivative of 2 to power x is 2 to power x multiplied by ln of 2. Because the base is not equal to e in this case. So we must have ln of 2. Again, the derivative for logarithm is f prime over f. We differentiate, we apply the rule of the logarithmic function, derivative of the logarithm, which is f prime divided by f of x. So it is 2 to power x multiplied by ln of 2 divided by 2 to power x minus 1. Number 8, if we have y equal to 3 to power ln of square minus 1. Y equal to 3 to power ln of x square minus 1. The derivative for this function, y prime is equal to, since we have exponential function, so it will be the same as in the first step. It is 3 to power ln of x square minus 1 multiplied by. Now in the second step, we need to find the derivative of the power. Now derivative of ln, we know it is x square minus 1 in the denominator, and then we take the derivative of the function, which is 2x. So it is 2x divided by x square minus 1 multiplied by one more step. Since the base is not e, then we must have ln of the base, ln of 3. So that's it. This is the derivative. Y prime equal to 3 to power ln of x square minus 1 multiplied by 2x divided by x square minus 1 multiplied by ln of the base, which is 3 in this case. So this is the derivative of the exponential function. Can I take one more? That will be number 9. Y equal to e to power, take tangent. So the derivative of this one, y prime, is equal to the function as it is, e to power tangent multiplied by the derivative of the power. Derivative of tangent is equal to secant square. That's it. This is the derivative, y prime equal to e to power tangent multiplied by derivative of the power, which is secant square of x. Last example, number 10. Let's have that y equal to 5 to power tangent square of square root of x. 5 to power tangent square of square root of x, exponential function. So the derivative in this case, y prime equal to, first of all, it is the function as it is, 5 to power tangent square root of x multiplied by the derivative of the power. Now the power consists of 3 functions. The power itself, it is square, tangent, and square root of x. And from the chain rule, we differentiate the power first. I have power, I have tangent, I have square root of x. These are the three functions. So in the first step, I will differentiate the power, which is 2 multiplied by to be 2 multiplied by tangent square root of x. This is step number 1. We differentiate only the power. Now, number 2, we differentiate the tangent, which is inside the power, which is the second function. Derivative of tangent is secant square. So this was number 1, this is number 2. So we are done from the second one. Now we differentiate the third one. That is the derivative of square root is 1 over 2 square root of x. So it will be 5 to power tangent square root of x multiplied by 2 multiplied by tangent square root of x. Then we differentiate tangent. I will get secant square root of x multiplied by 1 over 2 square root of x. That is the derivative of the square root of x, the angle. But don't forget, still we have one more. One more is the base. So this must be multiplied by ln of 5. So the base is not equal to e. So we have to write it. It is multiplied by ln of 5. So this is the derivative of the function now. Y prime equal to 5 to the power tangent square root of x multiplied by derivative of the power. We apply the chain rule. The power first, 2 tangent square root of x. Then we differentiate tangent. We got secant square. Then we differentiate the angle. We got 1 over 2 square root of x. And in the last step, we multiplied by ln of the base, which is ln of 5 in this case.